Okay, today's lesson has to do with finding the missing angle when you have parallel lines cut by a transversal. Right here, I have parallel lines cut by a transversal. This is my transversal, and these are the parallel lines. M and N are the parallel lines. So we're given some information. You always have to look to see what information you're given. It's saying that in this figure, the measure of angle 2 equals 75, meaning the measure of angle 2 is 75 degrees. The first thing you want to do is fill in the information in the diagram. So angle 2 is 75 degrees. You want to write that down. And then it says find the measures of the remaining angles. So we're going to use what we learned in the last few days in my class to figure out the other angles. So for example, 75 is angle 2. That must mean that angle 6 is also 75 degrees. So angle 6 is 75 degrees, and angle 6 is corresponding to angle 2, which means they're congruent. Your homework last night had you decide what theorems and postulates meant that angles were congruent versus supplementary. So the corresponding angles will always be congruent, and that's been proven. So you can say angle 6 is congruent to angle 2 because they are corresponding angles. Now we can look at some other ones. We can say that angle 2 and angle 1 must add up to 180 degrees. So they are supplementary or a linear pair. So that makes this, angle 1, 105 degrees, because 105 plus 75 is 180 degrees. So those are supplementary angles. So angle 1 is supplementary to angle 2, and they're also a linear pair. Two angles on a line that are supplementary. We can also say that angle 8 and angle 2 are also the same, and 8 and 2 are the same for a different reason. Angle 8 and angle 2 are exterior or alternate exterior angles. That's one of your vocab words. Alternate exterior angles, because they're on alternate sides of the transversal, which is this line, opposite sides, and they are on the exterior. Okay, so they are, so angle 8 is alternate exterior angle to angle 2. And alternate exterior angles are always congruent. So that's why we can say it's 75 degrees. We could say that angle 4 is vertical to angle 2. So we can say that angle 4 is vertical to angle 2, making those the same. So angle 4 is vertical to angle 2, making angle 4 75 degrees because vertical angles are congruent. Okay? We can say that angle 7, or actually let's say angle 7 is 105 degrees, because angle 7 and angle 1, now that we are told what angle 1 is, because it's a linear pair to angle 2, they are alternate sides of the transversal exterior angles. They're on the exterior of the parallel lines. Okay, so that makes them congruent. So angle 7 is an alternate exterior angle to angle 1. Angle 7 is alternate exterior angle to angle 1, making it 105 degrees. Now, angle 3 and angle 7, if we know angle 7, we can now look at angle 3 and say those are corresponding angles. So angle 3 and angle 7 are corresponding angles. Angle 3 and angle 7 are corresponding. Remember, that means they're in the same position. If you take the 4 angles up here and paste them down onto the angles down here, or move them down, 3 would land on 7. So that makes them congruent as well. So 3 and 7 have to be the same. All right, and the only other one that we have that we did not get a measurement for would be 5. And since we know 5 and 3 are both inside the parallel lines and on opposite sides or alternate sides of the transversal. So angle 5 and angle 3 are alternate interior angles. So that makes angle 5 105 degrees. So angle 5 is alternate interior to angle 3. That makes them congruent.